know what that sound means. Time for you to
Ms. Reed, I'm not sure if you heard me earlier. I was asking if the college has decided to switch classes to pass or fail versus being graded.
I have not heard anything about that aspect of it yet. I'm reading all my emails as I get them, so I'm not sure. But since we're still doing the same content that we've been doing, we're still doing. I figure, they may tell us to curve stuff at the end. I don't know. Well, it's a very good question, but we just don't have that decision given to us yet because their hope is still that they can we can move back to on campus later on.
Correct, and that's totally understandable. I was just figuring if they may be following Gadsden County school guidelines, considering they're going to be out until May 15th, and that's the time that we're going to be out of courses. So hopefully they make some type of decision there, considering this is a big thing for us for the math course that we're in.
Well, let me just tell you, let me reassure all of you that I promise that on my end, I will make sure that it is very doable to make the grade that you are hoping to make. Okay, and I'm sorry that mine's really dark right now. The sun's going down and it's coming in the back window right behind me. So until it actually gets down, it's going to be a little bit dark on my side for my picture. So sorry about that. If I had a different kind of lamp instead of where I'm set up at, there it's starting to get a little bit better, I think. But most of the stuff we're going to be doing tonight, I'm going to be writing out the notes for you, and we're going to go through some stuff. I want to do some practice with the binomial things for the calculator that we went through some of last class. As far as I showed you a little bit on the calculator, but there are 4 specific ones that I want to make sure you know how to get to and are able to use. For the other part of tonight, it's going through section 7.1 and 7.2, and those are mostly actually a review from where we were doing empirical rule, but now you've got 2 other words that they're introducing to you to where it's going to be doing the same types of things in order to find out what your probabilities are. Okay?
I got a quick question, Miss Reed.
Sure.
Hey, you know that chapter 5 test? It's the PDF.
Mm-hmm.
I printed it out. How do I couldn't get it to do online. So how can I get it to you?
Take it a picture and email it to me.
Okay, or just scan it. Can I scan it and okay, I'll do that then. Thank you.
You are very welcome. All right, so with your binomial distributions, okay, so this goes along with the end of your chapter 6. I'm going to change the camera view for you so you can see down here. And let me make it so I can see there. Okay. And if it gets blurry, I'm sorry about that. I'll try to make sure that I'm making it as clear as I can as we start each section. All right, so this is your end of your chapter 6 with your binomials. The biggest thing that we talked about last time was that with the stuff that is binomials, you have to check the bins. So you're checking for if it is binomial. So if you have 2, you're checking for if it's independent, if one probability does not affect the other. You're checking for a fixed number of times that something is going to be done. And then there is your probability of success is not changing, okay? So that's checking your bins. I've got a few problems I want us to look at together. Now, I have this in a typed up format. This will be uploaded to Blackboard a little bit later, but I'm just getting it from there we go. Okay, So I'll get this uploaded so that everybody will have a copy of it if you choose to go back and look at it again. The biggest thing I want to show you is how you determine what stuff you're going to need, because not everything is going to be equals when we're doing the binomial types of problems. Some things are going to be greater than, less than or equal to, or something along those lines. Okay. If you're just joining us, please make sure you type your name in the chat box, and please make sure that you have muted your mic. I'm still hearing background noise from somebody's area. Okay. All right. So right here for this particular problem, it says 80% of the graduates of Northeast High who apply to Penn State University are admitted. Last year, there were 6 graduates from Northeast who applied to Penn State. What is the probability that 4 were admitted? So on this one, our 80% is our probability of success. That's our p-value, okay? Then over here, where it told us that there were 6 who applied, that's going to tell us our grand total. So that is our trials. Or in other words, in our formulas where we have an n, a p, and a particular number, okay, this is our number of trials that we're going to have. This is your n. Okay, then where it wants to say 4 were admitted, this is the probability you're going to figure out. So that 4 were admitted, this is going to be the number that we're looking at. So in our formula, we're going to have the probability, so p parentheses, that x would equal 4. In order to figure that out, we're going to do our binomial, B-I-N-O-M, and this time because it's an equals, it's a PDF, and the numbers we're going to have that go in our parentheses right after that is your n, then your p, and then your number that it's asking for. So the n was our 80%, so that would be 0.80. Our p is our probability. Oh, I'm sorry, I switched those up. The n was our number of trials. That's our 6. Our probability is our 0.80, and the number that we're looking for to get admitted is our 4. So to do this in the calculator, we're going to go get it pulled up. We're going to go on our calculator here, and we're going to go to second, and we're going to go to VARS. And right here, that first one is our normal PDF. We hit enter on that one. And that X value is the one that's saying, okay, well, what's the number that it's looking for us? Well, for that one, oh, wait, did they switch it on me? Yes, they did. Sorry. So it'll be the X value is first, and that with whether it's asking for in the menu. Wait, I'm sorry. I picked the wrong one. That says normal PDF. Let me go back. I picked normal. We need binomial. Scroll down. That was what I missed. Binomial PDF. Okay, so there's our number of trials, which we said was 6. And your p-value, your probability of success, it said 80% were the ones that were accepted. So we put in 0.8. Our X value it wants to know about are 4 that are admitted. So that's going to be a 4. We hit enter and let it run its course. And so our probability for this particular one would be 0.24576. Okay. Now on the next one over, now we're getting into the ones where there are greater than, less than or equal to, or something along those lines. For this one says more than 4 were admitted. So now we're dealing with P, the probability that X is going to be greater than 4. Okay? When we have ones that are greater than, less than or equal, we can still use our binomial function in our calculator, but now we're dealing with a binomial CDF because it's cumulative. It's going from one point up through an infinity, up to another number, something along those lines where it's not just one specific equals value like it is right here, okay? So I want to give you the 4 formulas that you can use for these, and then we'll go through that one specifically, okay? So the one that we had previously was when we had probability that X equals some number. Our formula there is taking the binomial P and then we have our N, our P, and then whatever number it's asking about that's next to our X, okay? When we start getting into the greater thans, less thans, and all that stuff, if we start with this one, probability that X would be less than or equal to some number. This particular one would do binomial, B-I-N-O-M, but this time instead of the PDF function, you're picking the CDF for the cumulative, okay? And you still have your N and your P and the number that it's asking about. So the biggest difference right here is because now with this less than part, this less than or equal to, now it's got to be the cumulative function because we're going from one place up through another one. Now the counter to less than or equal to would be greater than. So our probability that X would be greater than some number, since it's the counter or the opposite of, we're just going to do 1 because of 100% minus this binomial right here. So our binomial CDF of our N, our P, and the number it was asking about, okay? Because a less than or equal put with a greater than of the same number is going to fill an entire number line, all right? So instead of instead of less than or equal, if I just said less than, where I don't have the or equal part of it, X less than a number. That means I'd have all the numbers that were behind it, not including the number it's specifically talking about. So the way this one's set up is I do binomial, CDF, but this time since I can't touch this number right here, I pick the number directly 1 less than whatever it's asking about, okay? I still have my N, I have my P, but my number is 1 less. So let me give you an example of what that would be. So if they said probability that X is less than 4, then I would set this up to be binomial CDF of whatever my N was, whatever my P was, but the number I would use here, it would be a 3. It's going to be whatever the next number is down from the number that it was specifically talking about. That makes sense to everybody. Y'all have all blocked out your faces. I can't see thumbs up or anything.
Do
right.
an example, Miss Reed, will you?
Okay. All right, so let's pick one over here. It might say that they have tire failure is 40% of 10 tires tried. What's the probability that less than 3 fail? Okay, so right here I've got a probability given to me, so that's my 40%. I've got a set number of tires that they tested, which is 10, and I'm asked about a specific probability right here, less than 3. So for this one, I would set it up, what's my probability that X is going to be less than 3? I'm going to check my bins first. Is it binomial? Well, yes, it's either going to fail or it's going to not fail. The independent, well, if one fails, it doesn't determine if something else does. Set number, yes, I have 10 set tires that we're going to test. And does the probability of success stay the same for every single trial? Yes. All of those things apply, so I can do my binomial distribution stuff for this one right here. So I'm going to take it and do my formula of binomial CDF. The number that I have grand total that I'm trying is 10 tires. The probability that one fails is 40%, so 0.40. and that less than 3 fail. So since right here I've got less than 3, I can't touch the 3. It doesn't say or equal to. So that means the number I'm going to use is 1 behind it, which would be 2. Okay? Does the setup make sense?
Yes.
Okay. So then if we take our calculator and we go into second vars, I can get it on. There we go. Second and vars. Okay, then you're going to scroll down to where you have your binomials. Right there, you have a PDF or a CDF. Make sure the one you are picking has to match up. Any ones that have inequalities will always be CDF. Anything that has just an equals is PDF. So the equals are specific points. That's how I always remember it. So the equals is going to be PDF. It's the only one that has that. All the others are CDF. So we pick our binomial CDF function. Then we would enter our 10, our 0.4, and our 2, and we let it run. And our probability that less than 3 tires fail be 0.16728, or in other words, 16.7%. Okay? Questions on this problem?
Why are you putting a 2?
Because it was less than. If it had said less than or equal, I would have used 3. But if it says less than, you can't actually go all the way up to 3. It's got to be behind the 3. So the very next number that's behind the 3 would be a 2. Okay? Think of it this way. On a number line, let me pull this up here. When we were doing algebra stuff a long time ago, okay, where if it said x is greater than or equal to 4, okay, greater than or equal to 4, I would put 4 on the number line. Because it has or equal, I would shade it in and include it, and then I would shade greater. Agreed? But if I say x less than 3, that means 3, where it is on the number line, I can't touch it because it's less than. It won't equal it. So I'd have to use an open circle. So that means I'm going to get really close to it, but not actually use it. And then less than, I can be everything behind it. So the closest number, when we're talking binomial stuff, and we said it is or it isn't, there's no in-betweens on binomials. So the very next number that this could be would be a 2. Okay, we need to mute mics. Okay, so does that help? All right, well, let me give you the rest of these formulas here, and we'll work through a couple others. So we did the less than, we did the less than or equal, and we did the greater than. So since the less than is the one less, okay, so your formula for less than is your binomial CDF. You have your N, you have your P, and you have a number that's 1 less. The counterpart to a less than would be a greater than or equal. So if you have a greater than or equal, since it's the counter to this, we're going to do a 1 minus binomial CDF of your N, your P, and then your number that's 1 less. Okay? So there's 4 formulas with the greater thans, less than or equal, greater than or equal. Then you have your equals, which is the only one with a PDF. Okay? let's do this one. Okay, so here's your example. You've got National Health Institute says that 32% of women suffer hip fractures. Okay. If 10 women are tested, what is the probability that 2 or more suffer a fracture? Okay, 32% of women suffer a hip fracture. If 10 women are tested, what is the probability that 2 or more suffer a fracture? So right here, first thing we're going to do is check the bins. Is it binomial? Well, they're going to either suffer the hip fracture or they're not. So there's a yes or a no type of option here. The 10 women, that's a specific number. They're only testing 10 of them. So that's our set number of trials. When it's asking about probability of 2 or more, there we have our greater than or equal to 2. So we'll set this one up, probability that our x is going to be greater than or equal to 2 because it said 2 or more. So that means I can include 2. So my greater than or equal to formula, I go up here and match it up with the formula that I have written. That's going to be our 1 minus our binomial CDF. The n is our number of trials, which is 10. Our p is our probability, which is our 32%, so 0.32. And I'm going to use 1 less than this number right here, so I'm going to be putting a 1 right there. Okay? So everybody see where my numbers came from?
Yes.
Okay. So now if we go into our calculator and we go to our second and our vars, keeps cutting off on me. Second and vars. Okay, and then scroll down. That's where you're going to find that binomial CDF. Now, if you want to do your 1 with it before you start, type the 1 before you go to the second and vars, or if you go ahead and do second vars and get what you need for this piece of it, then make sure you do the 1 minus it. Okay, but if you want to do everything in one step, then start with the 1, put your minus, and then do your second vars to pull it up because it'll go right on the screen right after you pick it.
Oh, wait a minute. Will you back up a little bit? What was you saying?
If you want to do it all in one step, start by putting 1 and then minus on your screen before you go and do the second and vars to pick up the binomial CDF piece. So if you do a 1, then your minus, then go to your second and your vars, scroll down to the binomial CDF, then we'll put in our 10, put in our 0.32, and we'll put in our 1. And so now, like if I scroll across, you can see it's got the 1 minus the whole binomial CDF stuff. And all those numbers are in place. And then I hit enter. So it should end up giving me 0.87938. So the probability that at least 2 or more are going to suffer a hip fracture would be about 87.9%. Okay. Is this helping us going through these?
Yes.
Okay.
I had a question.
Sure.
So the formula for the when it's the x equals the number,
Yes.
that's the one that we do the binom PDF.
Correct. And that is the only one that gets a PDF in the entire course.
Okay, my next question is the one that's the x that is less than or equal to. That one, it just has the n, the p, and then the number.
Correct. It's the same number as you would use in the probability as you are using right here with the binomial CDF.
Okay, and then, so why is the other one that is the x that is greater than or equal to the number, why does that one have the number that's one less?
The reason why this one has the one that's one less is because its counterpart is less than. Okay, so the less than piece of it says we can't use that number. All right, so but since all of our binomial CDFs are finding an area to the left kind of what we're dealing with in our normal curve, which we're going to be going through in just a minute as far as visually seeing what it's doing. But for this one, because it's one less, it's taken, okay, well, up to, because where we had like 3 or something, it's taken all the way as close as it can get to there by using 2 to tell what that probability is going to be for this kind of shaded area that would be right here. But when we talk about greater than or equal, that means it's going to have that one included and going to the right for greater than or equal. So to get that counterpart, this one, I just have to subtract from 1 to get that opposite side right there. So that's why, because I'm using the less than piece to give me my greater than or equal to. That's why this does not change.
Okay, I understand it. Thank you.
You're welcome. And to be perfectly honest, guys, the biggest and easiest way I think that I always remember these, because these are not things that they're going to hand you like on a formula sheet, but you know, depending on if they let us do our exam online, which, you know, I think would be great, then hey, you can have your own formula sheet right there with you. If you think about it this way and make you a list, if you've got your x equals your number, that's your only one that is your binomial PDF. And it'll be the n, the p, and the number that you have. Okay? Let me refocus it real quick. There we go. Then we have all of our less than, greater than, and all those guys. Start with the one that looks the same, which is your less than or equal. And if you do less than or equal, the only thing that changes from this one to this one is what letter? PDF changes to
CDF.
CDF. And we still have our N, our P, and our number. Okay? Counterpart to a less than or equal is a greater than. So anytime you're doing a counterpart, it's just 1 minus everything that was here, exactly the same. Okay, so that's my pair, less than or equal and my greater than. So I write them like that when I'm writing them down in my formula list so that I make sure that I'm matching those two things up. And literally, the greater than or the greater than or equal are the only ones that have a 1 minus. Okay, so now the next one, if I did probability that x is less than some number, from the less than or equal standpoint, this one had the same number. So now since I don't have equals, I do 1 less. Okay. Then the counterpart to a less than would be a greater than or equal to. So since it's a counterpart, it's going to be a 1 minus everything I wrote right there. And this is all of your binomials formulas. Okay? Those are all of your binomial ones. So as long as you know where you're getting your n, you know where you're getting your p, and you know where you're getting your number, you can use your calculator to find any of these. Just keep this little shortcut, list near you until you get used to them, or rewrite them a few times, okay? And it'll make it a whole lot easier. Now, there's two other pieces that we talked about doing your mean if you had a table and stuff from the chapter 6 and all of that, but we didn't specifically talk about mean for binomials. You're going to encounter this, I think, a couple times in maybe some of your homework. But the mean for your binomials, to find it, it's just n times p. And it's the same n and p that you're using right here. So your n is your number of trials, and your p is your probability. Okay? The other piece is your standard deviation. Okay, so with your standard deviation, this one is going to be square root of n times p times 1 minus p. So again, the n and the p are the important pieces. So the number of trials and the probability. And these are just two formulas, and you're going to be given those number of trials and you're going to be given those probabilities every single time in the problems. It's not going to be like they're missing or something. It's going to be, find the mean, your n and your p. Okay. Now, if I go back to the very first question that was doing on this piece of paper, where we had the one about the graduates, the 80% rate that they were graduating kind of thing. If we look back at that one real quick, I'll move that up. Right here, where we had our 80%, we had 6 trials, and we wanted to find out about 4. If you were just asked, because this right down here, the mean of the distribution, if we already know it's binomial, the only two things you got to have is the n and the p. So all you would do would take your 6 number of trials times your 80%, and that's going to give you your mean. So if you do your 6 times your 0.8, that'll give you your mean. So I should end up with 4.8. Okay. For the standard deviation of this same problem, our formula would read square root of n times p times 1 minus p. Well, n is 6, because that's our 6 trials. Our probability of success is our 80%, so 0.8. Then I have 1 minus 0.8. And everything's under that square root. Now, when you type this one in, you can choose to go ahead and type it in with the square root, or you can choose to type it without. For me, I'll usually just go ahead and put the square root in it so I don't forget about it. Do the 6 times your 0.8 times your 1 minus your 0.8. And if you type it in exactly like you have it written, except I forgot parentheses around that one, but if you're really close to it, then that's going to give you what your standard deviation is for that particular distribution. Okay? Does that make sense? Okay, for those of you I can't hear you or see you, you either need to type yes in the box or I need a thumbs up visual.
Okay, Miss Reed, so you've got 6 times 0.8 minus 0.80. I don't know what the P is. What was the P?
Yes, the P is your probability of success. So that's the 80% that it was talking about in the beginning of the problem. Yes, Annette, I will be uploading the notes from this example and everything too. So yes, all of it will be uploaded. So right here under this one, we took our N, which was our number of trials, and then we took our P, which was our probability of success of 80%. So I used 0.8 times, and then 1 minus P is used a second time here. So I do a 1 minus 0.8 again. And once I type all that in under a square root, then I get 0.979 as my standard deviation.
Okay.
Okay. All right, so those were the biggies from the chapter 6. I wanted to make sure that you guys were okay with. All right, so now on to 7.1 and 7.2. They kind of go together because of the information that we've already gone over out of some of these. So I'm going to write them down together on here for us. So with the 7.1 and 7.2, remember when we went back and we had, think back to empirical rule, where we were talking standard normal curve, okay? That is what these two chapters are. Now before, when we were talking empirical rule, when we were finding probabilities, we were using the numbers that were exactly on a standard deviation line. In this chapter, the only difference in the entire thing is that now some of the numbers we're using are not on those standard deviation lines. So now we're going to get into a function in our calculator that can help us find those probabilities using our normal CDF function in our calculator if they don't fall on a standard deviation line. Okay? So now you've got two types that you're going to be dealing with. Okay? You have your standard normal, and this is going to be a phrase you're going to be on the lookout for. If something is telling you standard normal in any type of problem, in any word problem, in any kind of setup at all, okay, or you see a letter Z, okay, that Z represents that they're giving you a Z-score, okay.
No, Z-score, no.
Yes, Z-score is back. So our little refresher reminder, thinking bubble, we're going to remind ourselves that a Z-score is our X minus whatever mean we have and divide by our standard deviation. Okay, that's how we get that Z-score. Well, they're already going to hand it to you, but now we're going to say, all right, well, that's fine. I've got a Z-score. Find for me now what's the probability to the right of this Z-score, to the left of this Z-score, in between two Z-scores, okay? So one thing that you might see, it might say, find the probability on a standard normal curve of the probability of Z less than 1.2. Whoa, okay. So right now you're like, all right, well, I got a probability, but I don't have a lot of other information, okay? When you see this phrase right here, standard normal, this is the one that's going to be your, hey, I saw it, so now I know two things, okay? When you see that phrase, standard normal, two automatic things you're going to know is that your mean is automatically 0 and that your standard deviation is automatically 1 every time, okay? If you have a Z score, and you'll know it because they'll tell you it's a Z, and it says standard normal somewhere, you're going to know automatically your mean is 0 and your standard deviation is 1, okay? So similar to how we were doing our binomial functions a little bit ago, we're going to go into that same function menu in our calculator, but this one, because of the keyword normal, we're going to be using our normal distributions in the calculator to give us our probabilities, okay? So if I want to find this one right here, I'm going to go to my second and my vars. Okay, here so you guys can see. Okay, so I went to second, I went to vars, and because we're dealing in normal, right now. I'm going to pick one of my normal functions up here. Now here's the thing. This one has a PDF and this one has a CDF. This one right here says less than. What do you think I'm going to be picking? PDF or CDF? Let's vote. Put in the chat box if you think it's P or C. Woohoo! Good job. Yes, it's CDF. And the reason why is because it's an inequality here. Okay? We're dealing in cumulative. We're adding stuff up. So we're going to go down to our normal CDF and we're going to select it. Okay? Now, in the binomial, you needed 3 values. You entered your N, you entered your P, and then the number it was asking about. In this one, it tells you lower, it tells you upper, and then it gives you the mean, and it tells you the standard deviation. Okay? So that's what you're looking at. Let me move this a second. That's what you're looking at on your screen, are these guys right here. Okay? Now, thinking about this right here, what it would look like. I've got this curve. I've got something right around 1.2. Well, if my mean is automatically 0, I'm going to go ahead and label that. Standard deviation would be at 1. So I'm talking a little bit past that 1, and I'm going greater than. So I'm shading that direction. I'm finding this shaded area right here for that particular probability. So that means I'm going to start at that 1.2 that it's asking me about, and then I'm going all the way to the right. Well, the number that exists over here is infinity. Our calculator doesn't understand how to use infinity. So whenever we have something going to infinity, we type it in as 1E99. Okay? So to get that kind of E to show up, we type our 1, we would type our second, and the E that it's using is the comma button E, the one that has 2 capitalized E's over top of it. Okay, so that's where you're getting this little EE, but it'll be 1 capital E in the middle of it. And then you would put your 9 and your 9. Okay, so that's how you do infinity in the calculator. So now in looking at this part right here, what's my lower? My 1.2 or my 1E99? Which one's smaller? The 1.2. Okay, so that's going to go in for my lower. My upper that I'm going to be using is going to be my 1E99. Okay, the mean, because it said standard normal, is automatically going to be 0. And because it said standard normal, our standard deviation is going to be a 1. So when I'm typing this in, I'm going to put my 1.2 in for my lower. Okay. Then when it asks me for the upper, I'm going to hit 1, second, the comma button. See how it put the E right there? 99. Then my mean is 0. Standard deviation is 1. Let it run. And it's going to tell me right here is my probability. So my probability would be 0.115067, or about 11.5%. So that 11.5% is what's sitting in that shaded area right there on that curve. Okay. Now, the good thing with the normal one as opposed to the binomial ones, you are always able to pick. You have a number that you're starting at and a number that you're ending at. So you don't have to worry about, do I use a 1 minus or not use a 1 minus or any of that. Those are only with the binomial ones, okay? So let's do another example. Let's say that you're told you have a standard, normal distribution, and they want the probability between negative 1.1 and 2.04. Okay? Key phrase in the entire thing. Standard, normal. So automatically, it's seeing those two words. We know our mean is going to be 0. We know our standard deviation is going to be a 1. So I'm still going to use my same function that I had from before, my normal CDF. To get there, I go second, I go vars. So we'll do that together. I go to that normal CDF. And for this one, what's my lower number? 1.1, the negative 1.1 or the 2.04?
Negative 1.1.
Mm-hmm. So that's going to be the first one I'm going to use right there for my lower. Okay, so then my upper, my 2.04, will go next. And then since that key phrase, standard, normal, my mean will be 0, my standard deviation will be 1, let it run, and it gives us our probability. Okay, so this one, between these values, it would be about 84.3%. Well, if we're thinking about it, on a standard normal, like we were just talking about, if the mean is 0, every standard deviation would be at whole numbers. Okay. And we're wanting between negative 1.1, so that's about right there. And then my 2.04, just barely over the 2 line, we're looking for that area. Now, what you know from empirical rule, between the first standard deviations is already 68%, isn't it? So then if we're adding almost another bar over here, then that's where we're getting about 84.3% that we're dealing with in that shaded area. Okay? Does that make sense? Okay. So we did one that was greater than, we did one that was in between, so let's do one that's a less than. Okay? You have standard, normal, and I'm going to let you guys do this one. Okay? You have less than 2.2. Okay? Less than 2.2. You're still going to use your second, your vars, and your normal CDF. But what other number do you think you're going to need to finish this one out?
Negative 1E99.
Correct. Because in our picture with this one, okay, here might be 2.2 over here, but if I need to be less than, then I need to know what this negative infinity is. Well, that's that negative 1E99. So now you just have to determine who's upper and who's lower. So always read it left to right. So if you sketch it out, this number here on the left is going to be your lower. The left number is always your lower. So that's going to be your negative 1e99. Then your upper would be your 2.2. Your mean automatically is what?
0.
Perfect. Standard deviation?
1.
Yes. All right, I'll give you guys a second. Let's see what you get. Okay. Did I give you enough time? All right, so the normal CDF, once you run it, should be 0.98609. Give me a yes or no in the box if you're okay. Awesome. Awesome. Okay. So that is all of 7.1. They only change one thing in 7.2. So if you're okay with this, the only difference now is they give you a specific mean and a specific standard deviation. So instead of using 0 and 1, you use the mean and standard deviation that they might give you. Okay? Let me give you an example. So let's say that they say, let's find in a standard, well, they may not say standard, they may just say normal distribution with a mean of 50 and standard deviation of 7. Find the probability of being greater than 65. Okay? So the part that might be left out might be this word standard. But your word that you still have is normal. And if you see that word normal, you can use normal CDF in your calculator to find your probabilities. So this word right here tells us I can use that normal CDF function. Okay? They specifically give me a mean and a standard deviation. And they're telling me the one that they want me to find. So the way I would write this one down would be my probability that my value of X, so since they're not specifically stating a Z, I'm just going to use X because it's not a Z score at this point, because they're telling me a mean and a standard deviation. So I'm going to say X greater than my 65. Okay, so then to find this one, I'm going to use my normal CDF. Now, right here, you have 4 things you have to fill in. Okay, just like you did on your calculator. You have your lower, your upper, your mean, and your standard deviation. So right here it says greater than 65. Well, I've got this curve here. My mean is sitting at 50. So the 65 is somewhere over here. And it says greater than that. So I'm going this direction. So what two values am I going to be using?
Five and the 1E99.
I agree. So these guys are going to be my lower and my upper. So 65 would be the first one. My 1E99 will be my second one. And then my mean's going to come next. Well, they told me that one in the problem. So that's going to be my 50. Yep. And my 65. Oops, no, not 65. My 7, sorry. Mean and standard deviation. So right here was my lower. This one's my upper. This one's my mean. And that one's my standard deviation. And that is the only change from the 7-1 to the 7-2 is that they are specifically giving you in the problem the mean and the standard deviation as opposed to it just saying standard normal with nothing else there. Okay. Questions? All right, let me move my camera real quick so I can see you guys. Okay, so was it helpful?
Yes.
Okay,
Yes.
all right. So the biggest thing now is that I'll take this. I'll do like I did the last time. We'll run it as a video. I'll add it to Blackboard. I know there was a couple of people that had sent me a message as to why they couldn't be here or anything like that. There were some other things that came up. There were some questions some people had asked about because they may or may not have done so great on the last test. We can make arrangements to redo a test if you need to redo a test. Okay, so if there is one that you just crash and burn on, let me know. We'll look at it together and I'll give you an opportunity to redo it. Okay, so don't be afraid to ask. That's the biggest thing. Don't feel like, oh, I just can't do it. It's over. Please don't do that. Okay, you have absolutely every opportunity to make sure that you are in good here. Okay, and I will give you that opportunity. Your next test, let me go ahead. I had a schedule that I posted. Let me get my, here's my notes. All right, so we have ours that we just did tonight, and we went through the 7-1 and 7-2. On the 31st, we will meet again online at 6 o'clock. We're going to review problems for 6 and 7. So everything that we just went over again tonight, you're going to have some time to practice those things in some homework that's going to be up on Blackboard in just a minute. You don't have to do it tonight, but I'm just telling you that it's going to be up there and ready to go. But on the 31st, you will have chapter 6 and 7 tests available. Okay. Now the big part on this is that most of it is calculator based. You're finding exactly what we went over tonight. Using that normal CDF or using the binomial CDFs. Okay. So you can use your notes on it. You can, look over everything and make sure that you know your differences. And what we're going to look at together, we're going to do a few problems literally step by step like what we started with tonight. Highlight where we know what it tells us the problem is so we know what to use and when to use it. And then you guys will have time to get your test done. That test will be released on the 31st. It'll be due on the 9th of April. Okay. And so for the next bit, I've got us meeting on Tuesday and on Thursday at 6 o'clock. Okay. The next homework assignment I'll post tonight, but it is not going to be due right away. But if you can have it ready to talk about at least some of the problems in it when we meet on the 31st, I think it will help you. So at least get some time set aside where you can look through it. Okay. Let's see. And yes, Annette, I did get your email, and I'll be sending you something back this evening or tomorrow. Tesla first, got it. Okay, does anybody else have any other questions?
Has there been any updates from the school on like what the next couple of weeks are going to happen? Or we can still do through online, or are we going to do anything the school's recommending?
Everything is solely online for us, at least until we would be able to go back on campus. They closed campus for even all of the teachers and everybody now. And for the county, they closed it today, saying that by 5 o'clock tomorrow, it's only the, what do they call them? The necessity, I don't know, whatever the, yeah, it's the stay-at-home order. Only the essential people can go starting at 5 o'clock tomorrow.
Okay, thank you.
So, no problem. If y'all need me, you know where to find me. Email me, text me, whatever. Because of the fact that I've got a lot more coming in now as far as emails and texts, if for some reason I have not gotten back to you within a 24-hour period, feel free to send me something else again, because now, besides just, you guys, every single high school student I have is not waiting to ask me in person. So we are, they're doing all that stuff too. So they're blowing up my phone, and I'm trying to keep everything straight. But please let me know if I can be of assistance in any possible way. And I look forward to seeing you all next week. Okay. All right.
Thank you.
No problem.
Thank you, Ms. Reed.
Take care, guys.
Thank you.
Mm-hmm.